All right. Hello everyone. Oh, what? This was not expected. Can somebody let me know if the sound works, if like the audio quality is all right? If it is, just write something in chat. If it's not, um, then there's a problem. Works? Okay. So, what are you doing today? Let me set some context because otherwise kind of the task at hand will not be clear. So I am occasionally working on my project called meshoptimizer, and part of this consists of a lot of WebAssembly code, of some amount of WebAssembly code, and I'm starting to use WebAssembly CMD. And it's an extension that effectively allows you to write CMD, like 128-bit CMD code on the web, and it's a portable extension, so you can write the code once, and then it can, when you run it inside the browser, it can get compiled onto different architectures and give you good speedups. So that's all good. Now there's a problem. The problem is that right now the CMD extension is experimental, and it's implemented in Chrome. It works. It's all good. Now the problem is there's a specific encoding. So if you look at, let me see. So if I do so if I dump the disassembly of some file, right? Let me see if I can find some CMD instructions. Oh, this should be, yeah, okay. This should be here someplace. So here's some function. I'm not sure which function it is, but there's some function that uses shuffles, which is a CMD instruction, and then extract lane, which gets the first 32-bit integer out of 4 32-bit integers stored in the register and things like that, right? So these instructions have a certain encoding. So for example, the extract lane 0 is encoded as fd0d00. fd0d is the instruction and 0 is the argument, right? Now the question is, where is the mapping? Like, who says that extract lane is 0d? The answer is there is a specification for WebAssembly, and the specification right now somewhere lists all of this. So if I look at extract lane, right, then it says that it's encoded as 0d, followed by an index, which is just a byte. So that's all good and well. The problem is that this encoding is not final. And so there is an upcoming change that is going to happen where there's going to be some renumbering of the opcodes. And so if we look at the extract lane here it's not 0d, it's hex 18. Now, the reason why this is possible to do right now is that this is still all experimental. Like, to use CMD in the browser, you have to go to Chrome flags and set WebAssembly CMD support to enabled. By default, it's not enabled. So it's all still experimental, which is why there is an encoding change that still can happen. And the reason why the encoding change needs to happen is because the way this proposal is, I think, like a few years in the making, and instructions were kind of just added to this proposal one by one, and most of them just took like sequential opcodes in some places. wherever there was space, right? So now it's a bit of a mess because you look at you look at a floating point add versus floating point subtract, and they're like in one place, but floating point like max is in some different place potentially because it was added late. Now, the issue is, so this change will happen. What I'm worried about is that when this change happens, there's going to be a period of time where there's going to be some tools that support the old encodings and some tools that support the new encodings. In particular, so my project has integration tests or unit tests or whatever you want to call them. Let me see. So if I go to actions, which is GitHub Actions, and look at something, there's integration tests, and since this is WebAssembly, and it's kind of part of this whole web ecosystem, the easiest way to run tests is to run them in Node.js. So I run tests in Node.js, right? You pass it a flag, which says enable experimental CMD support, and then you can run your code and make sure that your code works. Now, I'm not sure which version of Node this is. 13.x, but Node lags behind the JavaScript engines, typically, V8 in this case. So what I'm worried about is that once this renumbering happens, you know, like I can get the latest compiler toolchain, and then I can use that to compile my code with the new instruction coding. So that's all good. I can probably even run this in Chrome as long as I run it in Chrome Canary or something like this, because that updates every day, basically, probably with latest interpreter. So that's also good. The problem is how am I going to test my code? And so it occurred to me that, well, the way to solve this, there's three ways to solve this, right? One way is to just give up on this, just wait up until Node.js gets a build that has the latest browser engine and things like that. And maybe that's what I'll do. We'll see. But if that doesn't happen, I kind of don't want to be in a position where I just can't work on this. Can't work on WebAssembly CMD code, right? For like a few months. I don't know how much time it could take, given right now in general, like it's not really clear what's going on in the world with like various software schedules, but also B, I don't think Node hasn't updated V8 in like a few months. Let's actually see. So if we go to Node.js and if you look at the latest nightly build, even, let's say, right, so if I look at the latest nightly build, oh, there's an installer, so it will overwrite my, let's see which node I have. Oh yeah, okay, I actually use a nightly build. Now, I never remember how to do this, so I have to Google all of this stuff. All right. So this is 7.9.3.17, and the latest version of V8 is like 8.2. And we can look at V8 release history to see when it was shipped. But something tells me it's been a while. October 2019, right? So the nightly build of Node.js, the latest build that you can possibly get. This is not the current nightly, but this is nightly from like a few weeks ago, right? Like March 7th. Has V8 JavaScript engine from October 2019. So this is what, like 5 months out. So I don't really have a lot of faith in V8 or in Node.js catching up quickly, but I want to be able to run my code. And so what we are going to do today is, right, so I don't want to just have this lag time where I'm just not using this technology. I could use the old version of the compiler toolchain to build the binary with an old encoding, and the new one to build the one with new encoding. But that's also suboptimal for various reasons. Like, I'm not sure how I can even set up the build process to do this. and it's just it's a pain, right? So the option that I thought of, and it's obvious if you do any web development, is to write a polyfill. So we can take our WebAssembly code that we have compiled, we can parse it, and then re-encode it using a different encoding sequence. Because the only thing this change is doing is it's literally changing the instruction sequences, right? It's changing the encoding from like 0D to 1.4 or something like this, and there is like 200 instructions here, so it's literally there's a table of instructions, and you just need to say, well, if it's a CMD instruction from the old world, I just need to map it to the new world, or vice versa. Now, for this to work, though, I need to write this code, and this means that I need to take the file that looks like this. So it's just a bunch of binary data, right? There is like a structure to this, but it's just a bunch of binary data. And then I need to take this file, I need to parse it, and then I need to re-encode the results. And I won't get the exact same file, but it will be mostly the same file. Now, I could obviously use a library to do this. I looked at, like JavaScript, and this also has to run in JavaScript because, I mean, I could write it in C technically, but I probably should just write it in JavaScript because this is what's running this code in the end. And so I looked at this, and there's like a package, right? But in typical web JavaScript style, it's a giant package, and I think this is the actual package that just does like parsing, but it's only the decoder, so I don't even know if it can encode. And it has like 15 dependencies, and it has like 2,000 lines of code. And so this is completely nuts because for what I need, like, I'm pretty sure I need like a page or two of code, not this monstrosity. And maybe I'm wrong. Maybe it just turns out this is really hard, but I need to solve a more constrained problem. I don't really care about all of these small bits that are encoded inside the file. As long as I can round trip them, as long as I can just like load them and save them back, it's fine. So let's try to do this. Maybe it'll be obvious that it's a stupid idea, maybe not. Two caveats: I don't really know JavaScript. The biggest JavaScript like thing that I wrote was, I guess, this file, which is 100 lines of JavaScript code, so you can tell that I'm a pro at this. And the other thing is, I don't actually know. I've worked for a while now with WebAssembly, but I actually have never looked at the binary file, so I don't know how it's encoded. Like, maybe it's very simple to parse, maybe it's really hard to parse. Who knows? So I don't really know what I'm getting into, but it doesn't really matter. Like, what matters is the journey, not the destination, right? Or something. So let's try to do this. The way we'll do this is we will go to the WebAssembly spec. Oh, and I should mention, like, the problem is basically there's a WebAssembly file that has some instructions that are CMD, but many instructions aren't even using CMD. So we will have to be able to parse basically all instructions from the spec, and also a bunch of things that might not be instructions. All right. As you can see, I actually looked briefly at the specs before, but I'm certainly not an expert in this. Scrolling is really slow here. Let's see if the browser catches up. I'm gonna do this. Yeah. And my goal really is to just be able to parse like one WebAssembly block. So I'm just gonna probably write this code like here in this file, in this one JavaScript file that I was able to write. Okay, scrolling is excruciatingly slow in this file, so we will not use the HTML version. Let's see what the PDF version. Okay, PDF version is much faster to scroll at least. This is like web for you. You can't even scroll through the WebAssembly spec, but okay. There's a multi-file HTML version, but you have to like navigate by clicking links. Maybe that's actually a better version. So what I want to do is I want to just understand the structure of the file, and then I just write a function that parses the file, and then we'll see what happens. So I need the binary format because I have a binary file. I don't really know where to start. Oh, and the only thing that I do know, because I had to look it up because there was some discussion about like some encoding issues, is that the binary file seems to be mostly just sort of structured, relatively structured format where you just say, okay, there's like sections, and for section you say there's a type and there's a length and things like that. And a lot of things are encoded just as bytes. For example, I guess here, right, the value type is just one of the 4 bytes. And a lot of things are encoded as integers, and integers are using this pretty standard, it's called LAB 128, but it's basically a variable integer encoding format where you encode the integer in 7-bit chunks, and each 7-bit chunk lives in a byte, and then the top bit of the byte determines whether there is a next byte after this. So this is pretty standard. Now, let's see, somewhere there should be like the outer structure of the file. So like if I look at this file, it starts with .awesome, right? And so somewhere there should be a thing that says the file starts with .awesome. One WASM file is called the module, so I'm assuming that I just need to understand how to parse the module. So like aha, here's the thing. Okay, cool. Alright, so it looks like we have this magic, which is just 4 bytes, and then we have the version, which is 1. Indeed. And then we have a bunch of sections. Oh, we have a fixed arrangement of sections. But that's fine, we don't really care. And I think, since I already very briefly looked at this, there was some section with code. Yeah, this guy. And this is the only one that we really should care about, ideally, hopefully, because we just need to, basically all other sections we can preserve as is, and the section with the code we'll have to decode and then re-encode using the new opcodes. Oh, I forgot to mention, this change hasn't happened yet, so there's not going to be a very easy way for me to test my code, but what I can do is, for example, I can take each instruction and add an op after every instruction, which in theory should mostly preserve the behavior of the code, hopefully. Is it right? Maybe not. But I would be content if I can even just like parse the thing and then reassemble the result, and the result matches what we started with, because then it's very, very straightforward for me to implement the actual opcode change after the fact. Alright, so oh, and the code section has the ID 10. Okay, so it looks like what we need to start with, and I'm gonna use Node, I guess, to run my JavaScript file. I thought about doing this in the browser, but like the benefit is there's going to be a debugger. Let me make the font larger so that people can see better. but then I would like it's going to be harder for me to iterate maybe or whatever. Let's just do this without the debugger and then we'll see. So I have this WebAssembly blob encoded in a string for reasons that I will not go into, but I have this function that can parse this. So really what we need to do is we need to say something like fix up cmd oh yeah, I mean, okay. This is not going to be super production code. My hope is that once I need this code, I can like add this code to my project, and then in 5 months or however long it takes Node to actually do this, I can remove this code. So now the input is basically an array of bytes, right? So I'll need some utility functions to read it, but that can probably come later. Or actually, maybe it could come now. Let me add a function that basically reads the byte. All right. Also, if anybody watching this really knows JavaScript, you probably will notice that I don't. Like, I probably should not be using var because var is an abomination. Like, I know how var works, so I know var is really, really horrible. But somehow I've used var everywhere here, so I guess I'm just gonna do that. Okay. So the first order of business is to parse the sections. So for this we need to skip this magic thingy and version and then go through the sections. And I don't really care about validating all of this, so I'm just gonna do the only hesitation is I need something where I will aggregate the results as well. Actually, no. For now, let me just parse the thing, and then we'll see. So to parse the thing, we'll need to skip magic and version. Just assume they're correct, and then oh, by the way, I forgot to mention this. I haven't streamed before using this keyboard. It's a new keyboard that I bought, which is mechanical. I'm really hoping the sound is not too obnoxious. I really like typing on this much more than on my older keyboards. This is the first time in my life that I'm using a mechanical keyboard, but it's really good. It's blue switches though, so it's like less terrible in terms of sound, but anyway, so let's look at the section layout. Hold on. 1 byte ID, and then the size in bytes. And I think the size is using this variadic encoding that I was talking about, because I think all integers are encoding using this. I don't know if this is true, but I'm assuming this is true. Let's try to see. So this is section number 1, I think. Because this is the version, yes. Oh, actually, wait. How are these ordered? Yeah, these are like this. Yes. So this is section number 1, which is type. And then there's a length, which presumably is hex 26. And then there's some other stuff. Okay, cool. So let's start by, oh, and the nice thing, this is a common layout actually, like a lot of files use something like this. The nice thing about this, I'm really happy, is for sections that I don't care about, which is almost all of them, I can just like skip them completely. Because I know how big they are, so I can just copy the bytes to the output. The only thing I'm not sure about is whether I will need to do something with like our for example, oh no, okay, function index. Okay, all right. So yeah, so I should be able to basically just skip over everything that I don't care about. The only thing I care about is code, which has ID 10. So let's just parse the thing. Now I will need the function that reads this beautiful like little endian format, so I will have to write this, and then the actual contents, yeah, okay, and then I just do offset plus equals of slan. So the way these integers are encoded is that you need to read bytes up until you find the byte that has the top bit set to 0. And normally you have to be careful about things like ideally the byte sequence that you're reading is limited in size, but we don't really care because we will trust our input, and if our input is wrong, like it'll just explode somewhere later, so it doesn't really matter. So the way you usually do this basically is you start with 0 and then you say I guess do so you read the byte and then you need to add the 7 bits of the byte. So the least significant 7 bits of the byte to the output value shifted by the current shift address. And every time you read 7 bits, the next 7 bits are going to be read to the next 7 bits of the result. And then you continue reading while you have the top bit set. And that should be it. And maybe this should work. This doesn't work. Didn't even print anything. This is where I'm starting to regret my choice of not using a debugger. Oh, great. JavaScript. Okay. This is why I should have written this in C or something else and compiled it to WebAssembly and dealt with it. Okay. I don't know. Okay, great. Why does it not even... Oh my god. Well, I guess I'm just... Yeah. Okay. I'm spoiled. Hold on. Hold on a second. Hold on a second. Alright, see, so I'm spoiled by languages that are nice. Lua, many people don't like Lua. I don't really get them because I know people who don't like Lua, but they like JavaScript. And so seeing Lua, if it's still not a type-safe language, etc., but if you do something completely boneheaded, right? Like essentially the code that I had there boiled down to this, right? I don't know how to get the length of this array, so I thought it's dot length, it's not dot length. And then I use dot length, and then it just silently works because JavaScript is stupid, right? In Lua, like you can read the thing from the table, but at least if you compare it, something explodes. All right. So how do I get the length? Wait. Hold on. Oh, because it's not uint array, it's, oh god, okay, hold on. It's like a buffer. It's an array buffer. Okay, that doesn't work for me anyway, so I need to do something like this. Data is like the worst variable name that I could have come up with, but it's fine. All right, and it's length, not count. All right, okay, finally. So this looks good. Oh, it's cute that it like highlights the numbers in a different way. So this looks good. The section number 10 is the section with the code. As you can see, it's the largest one. This is the only one we need. Ideally, I also need to no, it's fine. I'll do it later. Okay. So if it's a section with code, then we need to parse it further, and then we need to actually start looking into the instruction encoding and things like that. Let's see. So it starts. Oof. The text is a bit ambiguous, and this notation is a bit hard to read, which is great. So this section is it just like a vector of the code objects? And the vector thing is, oh great, aha, is just a length and then the elements. Let's test this. So this is gonna be, yeah, okay, that's fine. We'll temporarily, like, because we parse the whole thing in sequence, once we started parsing a section, we need to parse it till the end. So really, this means we don't know what the section is, and this means we need to parse it correctly. But for now, we'll just break out of the loop because I wanna like understand what the encoding structure. I just wanna clarify, I guess, what the encoding structure is. Okay. I think 11 is about the number of functions that we have. That sounds right to me. Or I guess code entry, yeah. So so we'll go over all of the code entries. For each code entry, we have the size of the code in bytes and the code. Okay. So this thing, the code starts with the local variables, and then there's an actual like code. And local variables, each variable is an index or something, and then the type, which I think is just a byte. Oh, but it pretends. Okay. Okay. All right. So we need to parse the local count. For each local, we need to read like 2 integers. I don't really know what they are, but I don't really care. And ideally, like later, I will need to write this, all of this stuff back, right? But let's just skip this for now. And after this, there is the actual expression. And so this is the part that's going to be hard, I think. Or maybe not. Well, I'm assuming it's going to be slightly painful at least. Alright, so the instructions, the expression is an instruction sequence terminated by an opcode B. Which doesn't tell me much yet because I don't know, for example, if this opcode can occur inside the body. Presumably not. Oh, so because we know how long the entire code section is, we actually can say, we not actually know where it ends. So here we can say, is there like, I forgot console assert? Yeah. Writes an error message to the console. Wait, what? Is there like an assertion that breaks the program? Is it only in Node? Oh my god. Okay, alright. Okay, whatever. Console assert it is. So really what should happen is that we should have parsed basically like here, once we start parsing the expression, we need to parse the entire expression. Oh, if you're familiar with like assembly, oh, I guess this answers my questions about, and like there's definitely end opcodes in the middle. If you're familiar with assembly, then I guess WebAssembly is sort of similar to what you might expect, but sort of different. I think the biggest difference is that it's a stack machine. So there's 2 big differences, I guess, that I know of. One is it's a stack machine, and the other one is that control flow is explicit. So there is not really like arbitrary jumps. Like there is an explicit loop opcode, which is kind of unusual. And if you look at the add instruction, for example, it just says add. It doesn't say what it needs to add. What it adds is that it adds the last 2 locations on the stack. This is kind of unusual in the, I guess it happens in, so like Java bytecode is the same way. It's a stack based bytecode. It's unusual in native like instruction encodings, right? Like you don't see this in ARM, you don't see this in x86. None of these are stack machines, but the WebAssembly thing is a stack machine. Now the challenge is this. For each instruction that we are parsing, so here's our function, right? It starts with like locals. Oh, this is what the number meant. The number meant that there's 5 locals that have the type integer 30. Okay. But then we need to parse these instructions, and then we need to end like where we need to end. And instructions are variable width, right? So like this instruction is just 1 byte. And this instruction is clearly 2 bytes, and it's because it has the instruction byte and then like other stuff. And so what this means is that as we read through this, we need to look at the instruction code, and then based on the instruction code, we will know what happens after this. Now, the nice thing is that a lot of the instruction codes are very similar. So if you look at this, right, like all of these instructions are really just 1 byte, and we don't really care what they mean, because like our goal isn't to write a disassembler or anything like this. Our goal is to be able to parse a sequence and then to emit a sequence that's almost exactly the same, but maybe some opcodes are slightly different, right? Because of this, we really only need to parse an instruction in as much as it tells us how like sort of how many bytes we need to skip after the instruction opcode, right? But really it's slightly more challenging because we need to know like what exactly are these bytes, how are they encoded, right? So, but either way, I guess the way it has to work is that we just have a like while loop or something. Oh, wait. Oh, hold on. Interesting. So there's this end instruction that says when the stream of instructions has ended, but it's not unique like it happens before in the instruction stream. So really what we have to do is we have to track like the depth. I'm assuming that the end is just used to terminate loops and like ifs and things like this or whatever. Let's check this. And so what we might need to do is we might need to track like how deep we are in the nesting structure of the program, so that when we see an end instruction, we can say, well, it's the end instruction that terminates the function, as opposed to an end instruction that terminates like the loop or something like that. So let's see if this is true. One alternative possibility is that we can just do a recursive parse, where if we see a loop or something like this, we just recurse and like call the same thing, which could be fine. I don't particularly want to do this. It's not like it's problematic in any real way. It's just, I don't know, it feels slightly weird to do this. But maybe we don't need this. Let's see. Oh, this is nice. Okay. It looks to me like the WebAssembly spec was more or less designed to just parse this top to bottom in like a non-recursive fashion, just in like a stupid way. Which makes sense because one of the points of the WebAssembly was that you can write a really fast code generator for it that can produce machine code, that can produce efficient machine code quickly. Alright, so what we will do is this. I don't know if this will work, but it seems like it should. So we will track the depth, the nesting depth, how far we are like down the chain of the instructions. And then we will read an instruction, and then in some cases we might need to increment the depth, and in some cases we might need to decrement the depth, and then if the depth reaches 0 again, or I guess if it goes from 0 to like -1 or something, then we are done. Alright. So, are instructions bytes or are they, right, instructions are single bytes here. So now we just need like a switch case statement or something. Let's say that we parse the thing. All right. Oh, is it? I see. When I look at chat, then I'm basically invisible, but when I write code... Oh, am I like invisible when I write code as well? Because there's no... Let me turn the lights on. I didn't really realize this. I don't have super good lighting, but it's better than nothing. Alright. I guess I can switch the color scheme, whatever. It's a weird problem to solve. I don't care. Alright, so once we've read an instruction, let's go back to the spec. Basically, we just need a switch statement. Or on one hand, I kind of want a switch statement because there's a lot of there's a bunch of instructions that have slightly different decoding rules. On the other hand, like if an instruction is one of these guys, then I don't really care which one it is again, right? I just need to say parse this mem-arg, however it's encoded, and just continue. So in some languages, you can say switch case, and then your case can work on a range. Like GCC has an extension like this. I'm not sure if JavaScript does. Oh. Oh God. What? Okay. Alright. So JavaScript does not do this. Alright, we will not use a switch case then. A lot of these are actually... Yeah. We don't really... Okay, that's fine. So most of the instructions are just a single byte. A lot of the instructions are just a single byte. So really we need to special case everything that has data. And then if it's a block like this, then we need to special case it and like adjust the depth while we parse. What's a block type? Okay, I guess it's a byte. Oh, come on, okay. So these guys are all basically the same. And what they represent is that I need to parse the block type, and then I need to increment the depth. And then I need to parse, and then I need to continue parsing these instructions up until I see the end, and then I need to decrement the depth. So this is 2, 3, and 4. Block type, and then I just need to go forward. So then there's a couple of instructions where I need to read presumably an integer. All of these are just integers, yeah. So, oh, wait. So it's a C and D. I need to handle this one specially. Basically, this guy. So this guy has an extra 0 at the end for some reason, which is odd, but okay. And then these guys have an integer after them. The beauty of all of this is that I kind of don't really care again about like instructions that are invalid or anything like this. So this entire range from this guy to like this basically has an extra byte, an extra integer. Because I think this is also an integer. Oh no, this is two integers. Oh dear. Okay. All right, never mind. I'm just gonna do this then. All right. So these CD10 and these guys. There's just a single index of something after it. So then this one, which we didn't handle yet, has like a vector of indices. Why does it keep jumping someplace? So it has a vector of indices and one more index. Oh, that makes sense actually. And like if all of this works, then I will be able to, everything that I'm saving into a local variable basically just has to be written back to the stream and things will work, hopefully. I don't even, there might be an easier way to write it back later, but it doesn't really matter for now. So, alright, so I handled this one. I didn't handle this. So this guy for some reason has a type index and a 0 after this. For reasons unknown. Alright, then these guys are just not interesting, so I'm just gonna parse them later. So these guys have one integer. Oh, never mind, I already did this here. Right, so these guys have two integers after them. This is the alignment and the offset. E. These guys have a single 0 after them for some reason. Oh, this is like the index of the memory block. Okay. All right. Alright, we are almost there actually, because all of the rest is just basic, like simple and boring, right? So we need to parse these guys. Oh. So this is where I realize okay. So then the two integer ones, so these guys specify like an integer constant, and then it's just, the beauty of this 7-bit encoding is that you actually can encode an integer of like an arbitrary length. So we don't really need to care, oh, is it a 30-bit integer, is it a 64-bit integer, is it like a 128-bit integer? It's basically all the same, which is nice. And then the floating point values look like they are just encoded as bytes. So if it's 43, we need to add 4. And then if it's 44, we need to add 8. And so then if there's an end instruction, then we need to decrement depth. And then this is just basically while depth is greater than 0. Okay. I did not handle any CMD instructions. I don't think this code will really work, but it might work on our scalar function. Oh, which is the one that we are working with. Okay. The code clearly goes into an infinite loop, so clearly it doesn't work. So clearly there's a bug somewhere. Thanks, JavaScript. Okay, hey, we actually parsed this correctly. I love the fact that in like there's no warnings, there's no nothing. How do people work in this language? It's painful. All right, so that's almost it, actually. Like, you know, believe it or not, we're like really close. We need to parse CMD code though. Like, I'm pretty sure. So right now we are parsing the WebAssembly code that I have in my library that doesn't use CMD. And this whole exercise is to parse CMD stuff. Oh, enable WASM CMD or something like this. Oh god. Okay. After like a bunch of attempts, I managed to enable CMD. Yeah, so at some point we basically failed to parse all of this because we aren't recognizing the CMD we aren't treating CMD instructions properly. So we need more specs. This is going really well. We need more specs, so we need to be able to parse CMD instructions. Also, I'm using one other like instruction set extension. Hold on. Where is it? This guy. In the baseline WebAssembly specification, there was no instructions for copying memory, which was a problem. But now it's there, which is good. So, I'm assuming this thing introduces some extra instructions somewhere as well. Aha. Okay. All right. Okay. So if the instruction is FC, then it's actually a prefix for the extension, which is called bulk memory operations, which we use. So we need to work with that. And so this encoding is kind of irregular, it looks like. Actually, so there is a cool shortcut that we can take. Now that I think about this stuff. let's first write this code for the code to work, and then we will like optimize the code. It's interesting that it uses 8, 9, A, B, C, D, E, but not... Am I missing something? Probably reuses the prefix with some other thing. Alright, so what do we need to do? So if it's 8, then there's uint and byte. The reason why all of this is marginally painful is that WebAssembly is like an interesting design space because it tries to hit so many different points kind of on the space. So it tries to be efficient to, like you should be able to write a parser, you should be able to write a code generator, you should be able to compile like C++ like code towards this instruction set. You also should be able to send this binary blob with a reasonably small number of bytes. Like encoding size is actually important because all of this, you know, is transmitted over the wire on the web. And because of this, like it would surely be nice if after each instruction, for example, there was a byte that said, and by the way, here's how large this instruction is. Because then, instead of all of this code, I could just be like, well, I read the instruction code, I skip the bytes of this instruction, unless it's like a CMD instruction, in which case I have to re-encode the instruction byte, right? But this is not how that works, because that would mean one more byte for each instruction, and that might mean like twice as big of a blob, right? So that's not cool, I guess. Anyhow, where were we? We were parsing this. Can you declare like duplicate variables in JavaScript, I wonder, with duplicate names? Let's test this. This encoding is mildly annoying because instead of grouping everything by like types of instruction, there's a bunch of similar instructions that are encoded almost the same way but are different in space. So C and 8 are basically the same encoding. B is... Oh no. Never mind. D is the same as 9. Okay, and E is the same as A. Okay, so, and then the other thing that we need is the actual CMD encoding. All right, and so the way this works is that there is an FD byte. If I miss anything, it was kind of a miracle that the basic WebAssembly parser like just worked after I fixed the stupid loop. because if this doesn't work, we'll need to debug this, and it's going to be slightly painful because it's a bit hard to know. Like, it's a bit hard to know where the first error is in the parser that goes like this, where half of the time you don't really care which byte it is. It's hard to kind of resynchronize and say, oh, hey, there is a bug here because you missed something. Anyway, so alright, so most of these instructions are similarly painless, right? They like, it doesn't take any, like you don't, it's not hard to parse them because they're just taking no inputs. And so we should just special case the ones that do. Alright, so these are memory instructions, so they do that thing. So this is a constant which just has 16 bytes worth of constants. So this is similar to like these guys where they just had a float or a double, but this instruction just has 16 bytes worth of data. So these guys, part of the reason why I'm doing this is I kind of want to look at the proposed instruction encoding from the point of view of decoding, like ease of decoding. Because, so see here, okay, so I need to parse like these guys, and I could just say if the instruction is after 5 but before 17, it has a lane index after this. But of course there's these weird instructions that like don't have it, and so this makes it more painful for me because I have to explicitly check, oh, is it like 5, 6, 7, 9, A, B, D, E, 10, 11, 13, 14, 16, 17, which is like weird. I guess what I could do is I could say if it's between 5 and 17 and not one of these like weird gaps, so 8 CF, still a lot. CF 12, 15. Oh god. Oof. So in this case, there's just an index. Alright, so then there's a bunch of just like nothing. We don't need. Oh, yeah, okay. Alright, so then there's these instruction that has also 16 bytes worth of data, but it's just like slightly different data. I'm just gonna plug this here. And there's these guys which are also loads. Okay. So maybe that's it, or maybe we have a bug and now we need to spend a bunch of time debugging. Oh, okay, we of course have a bug, so now we have to spend a bunch of time debugging the bug. That's unfortunate. Like, the problem is the bug could be anywhere in this code that we have just written, right? And these instructions are pretty big. Oh great, more doesn't work. Right. Oof. Okay. Alright, so this code does not work. Let's check if this scalar 1 still does. Okay, so this one is still good. So we haven't broken this accidentally. So basically the code doesn't work. What this means is that somewhere we are parsing an instruction incorrectly, and then everything else after this is just like it just breaks, right? And also, by the way, what should really happen, of course, is that if here we are reading out of bounds, then something should explode. So let's just say that if offset is out of bounds, how does this work? Okay. Right. Okay. And unfortunately, the problem is like, it's like, you know, with x86 code, basically any byte stream that you have is a possibly valid x86 program. So similarly here, it's not it's slightly non-trivial to figure out where exactly our problem is, right? Like where exactly is the first instruction that we decoded incorrectly, just because it could really be anywhere, and because we aren't recognizing instructions that are not valid, like it's likely to be later. So 127 is definitely not a correct instruction as far as I know, because it's just too large to be a valid instruction. So maybe the first thing we should do is that we should say, where's the actual spec? Oh god. Oh my god, what's going on in chat? I can like just ban everybody. I don't know. Or I can just not care and I will not publish the chat. Dear God. Alright, let me ban a few people. No, this removes the message. Ah, hold on. I never remember how to use this beautiful interface. Okay, I think this is right. I'm always wondering if these are like bots or what's going on. Ah, stop. Also, okay. No. Okay. Jesus. It's kind of amazing that YouTube hasn't like Google spends so much time on like various automatic moderation facilities and they don't work. I mean, maybe they do work. Oh hey, I'm almost there. All right. I think I contained the outbreak. Mostly. Okay. Oh my god. All right. Yeah, I don't really. I guess yeah, content ID is a bit different. I just mean in general, like my understanding is that, for example, YouTube does a lot of machine learning type stuff for comments on videos. Like it used to be the case that you open any video, it's completely impossible to read the comments because it's all spam, like what's happening right now in the chat, what was happening right now in the chat. But it kind of is not the case anymore. And so it's slightly surprising to me that they don't do similar things to live chat. Especially in the cases like this where it's just like a bunch of bots, I guess, I don't know, spamming the exact same message. It's odd. Anyway. So, where were we? We need to debug our code. So the first thing that we will do to debug our code is, so like, yeah, I have a binary stream, and at some point during parsing this binary stream, there is a problem. And I don't know where the problem is, but I'm pretty sure like 252 is not a valid instruction really. So the first thing I could do is I could say, I lost the spec. So we need binary format, instructions. So everything after BF is unlikely to be an instruction. And so what we can do is we can say, well, else if insertion greater or equal, greater than BF, it's probably not invalid instruction. It's probably not a valid instruction. So let's do this first. Okay, so this breaks like earlier. Oh, and this breaks right after the CMD instruction 18, which is 18 in decimal. So this is like 12 in hex. So maybe maybe we are lucky, maybe we just misparsed like that thing. Oh, is this the, okay, yeah, great, cool. All right, so that was better, sort of. Maybe not, maybe yes. So now we are breaking in a different place. Let me validate this line, like this thing. So between 5 and 17, excluding 8 CF 12 15. Yeah, okay, this seems correct to me. And all of these indices should just be like one small integer, so it shouldn't matter. 2. Oh, did I? No, this should be fine. C1. And then D2 through D7. Oh, I know what happened. And the worst part is it's my fault. Okay, hold on. I know what happened. this guy isn't correct. Oh dear. Okay. All right. So okay. Okay. We have fixed bugs. So the problem is, this is amazing, right? So I've actually contributed a bit to the WebAssembly specification. I've contributed a proposal for one instruction that got merged, and 3 instructions that are currently pending. I'm hoping that they get merged. And when I was proposing the instruction that did get merged, I didn't really know, like, it was the first thing that I've done for this, so I didn't really know what I was doing. So I proposed it. I proposed a new instruction. Like, the way this happened, there was an existing instruction that had this encoding 3. And I proposed a new instruction, and I just put it like someplace in the end. And then somebody was like, well, they are really the same they're really similar in terms of what they do, so maybe they should be close together. But of course there was no space like after 3, like the space for 4 was already taken, so I'm like, okay, it's fine. And the instruction that I proposed basically is this one. And so yeah, so somebody was like, well, somebody proposed basically just putting them in sequence, and I'm like, okay, that makes sense, right? That makes the encoding cleaner. And so then I just did this. I took the thing that was 3 before and made it C1. And like, the problem is, it's really a bad thing to do this in the middle of the proposal, because now suddenly you have 2 versions of the proposal that are different in the encoding on one instruction, and there's nothing major happened. It's just like somebody just merged my pull request, and suddenly instead of 3 it's C1. And of course in all of the existing implementations it's still 3, not C1, and it will never be C1, because after this renumbering goes through, it'll be something else. I don't know what it will be. Alright, and of course I hit that problem, which was hilarious, because it was my fault, just not like me on stream writing code that's bad, but my fault like months ago. Alright, so the good news is we have parsed the code correctly. Well, we don't know, but like, as far as we know, we have parsed the code section properly, and then there's a next section after this, forget what it was, which we also parsed. So this code probably works. Oh, like, it works, it's probably correct. So this is good. So the only thing, and this is like slightly more than a page of code, right? This is, so I said in the beginning that I will need 2 pages of code. We aren't writing the output yet, but this is, I have a large screen, but this is less than 2 pages of code. Now I'd like to make this code a bit more concise. And the way that I'm gonna do that is as follows. There's a couple of places here where we just read 1 byte. Like, so this thing, for example, I forget what it is, but it just basically reads 1 byte, which is 0. Like, the spec says it has to be a 0 byte. And I'm pretty sure that the reason why the spec says so is it's just they are reserving this byte for future compatibility. But once this compatibility actually gets like used, once they say, oh, okay, now it's not just 0, it can be something else as well, I'm pretty sure that they're just going to use this encoding. So really everywhere, I think, where we say read byte right now, we might as well just say read this integer thingy, right? And these guys were the same. So really, for example, here, this and this, it's exactly the same. It just reads 2 integers. It's just like 2 of them here right now happen to always be zeros, but we don't really care. And so I can simplify this code a bit by effectively saying this, and then if it's 0a or 0c or 0e, and then this. And I think I can do the same someplace else. So I think, right, so this guy, let me just replace this here. And so these guys are technically the same. It's sort of cheating to treat them exactly the same way, because this is like a memory load operation or something that has an alignment and offset, and this is like an index of something and 0. But really we don't care. As I was saying before, we don't need a full parser really. We need like enough of a parser to be dangerous, right? Like we need enough of a parser to be able to re-encode everything back. So because of this, I'm just gonna do, I guess, this. All right. Let me remove these logs for now. I can add them back, but at this point, basically, okay. Now, my goal, my ulterior motive, right, is to re-encode all of this stuff back. And really, the reason why I have to write this page of code is because when you look at the instruction, you don't know how many bytes it is. And this is really what this code does, right? It says that it's reading bytes, but really it's just reading bytes to be able to read enough of them to skip the instruction, right? Because of this is getting to like, I'd like to reassemble all of this stuff into a buffer that is the same code. It's just that I might need to change the opcodes later. So really what will happen is, this is the CMD branch, right? And this is the bulk memory extension. And so really what will happen is that here I will need to add some code that says, well, instead of writing this value back to the stream, which is the instruction opcode, write something else. Okay. Which yeah, that's fine. And technically we don't really need this anymore. It's useful for debugging, I guess, but we don't really need this. Anyway, where I'm going with this is that if I were to write all of this code back to the output, I would need to meticulously go through this, and like I would need to write a function that writes back the value in this format. Although I probably need this function anyway. Hold on. Oh, actually, oops, sorry. This is also same as this. So I can merge this here. Maybe this is simple enough. I'm not sure. Maybe this is simple enough. Let's try to add code that actually writes stuff. So now the thing I will need to fix, yeah, I will parse. I will publish this as a gist or something like this. This isn't gonna be fully ready today, right? Because for this to be fully ready, really, this proposal that renumbers the opcodes has to kind of be merged, and then I might have to change like this code to actually parse. My plan was not that I would parse the old thing and emit the new thing, because I can just recompile the new thing. So my plan was to parse the new thing and emit the old thing, which means that I would need to parse this and then remap these opcodes using like a table or something, right? Whereas just for every new opcode, I just have the old opcode and then emit the old thing. Meaning this block that parses CMD instructions will actually have to change. This stuff doesn't have to change because this stuff is the same. Like it isn't affected by this renaming. So so this code won't be fully ready, but yeah, I'll just publish this as a gist. It's a nice little sort of WebAssembly parser, right? So anyway, right. So let's like write code that just outputs all of this stuff back. The thing I'm not sure about is, so I think array buffers can't grow. The thing about this re-encoding process is that while it mostly preserves the values, there's this specific weird problem where the CMD extension actually encodes its opcode not as 1 byte, but as potentially 2 bytes. In fact, if we go back and say, this, any value that's more than 128, so like this one, more than 127, will be encoded as more than 1 byte, sorry. So this means that really this renumbering thing may change the length of code. And so what that means is that after I read the input, I need to write the output, but the output might actually be bigger than the input. And so this is JavaScript. I don't even know, like, I would like to just write backdata to the array of integers, but the array of integers are fixed size in JavaScript. So I want to say what I'm going to do is I'm going to make an array that's just going to be like twice as big, because it's basically guaranteed that the worst case scenario is that there is a bunch of single byte opcodes in my input and a bunch of 2 byte opcodes in my output. It's completely worst case. Like worst case is renumbering, like opcode renumbering changes single byte to double byte. And it will never happen, but this means that I'll just have an array and I just can write to this array and just can like not worry about stuff. Now I will need a separate write offset, so that's that. I guess I will need a write byte function. Right, so this is where I had the secret plan to not implement the write byte function. But maybe it's a bad plan. Yeah, I sort of like the plan. So my secret plan for not implementing all of the right code here was that, and actually this is neat because, yeah, okay, let's do this. So the secret plan goes like this. Instead of just doing this in one go, where we write things piece by piece and then write them back piece by piece, I will make a function that, is this a good idea? Seems like a good idea to me. It's really the special case though at this point. Yeah, okay. Never mind. You know what? I should just do the full thing. It doesn't matter, probably. Yeah. I will just do the full thing. It's fine. So to write an integer back in this interesting, like 7-bit chunk format, you have to write the values starting from the least significant bits, because when we were reading here, we were reading the least significant 7 bits and then the next least significant, next most significant, whatever. So what has to happen here then is that while the value hasn't reached 0, we need to write 7 bits to the output and then shift them out of the value. So we'll take the lowest 7 bits and then we will so if the value has extra bits basically, then we are gonna add a top bit, otherwise we're not gonna add the top bit. Shift by 7. Who knows if this is correct? This seems correct. And the other thing that I kind of want is I want a function that just copies a bunch of data, which basically would say increment offset by increment read offset by count, increment write offset by count, and copy the data. And there's a function to copy the data on this uint8 array stuff. I don't remember what it's called, but it's definitely there somewhere. Maybe. Oh, copy with then. You know what? Like, performance is extremely not an issue here, hopefully, because it's like, I don't know, it's like several kilobytes of WebAssembly code. It doesn't matter. No, wait, result right is equal to, and the names here are a bit weird, like I should probably call offset read instead of offset, so maybe I'll rename this. So now whenever I increment the offset, I can just say copy bytes. And whenever I read stuff, I can just write it back, which is nice. Maybe my original idea was actually a good idea. I don't know. Because now I have to be really careful. I have all of these things that I don't truly care about because they're just kind of framing the instructions, but I have to be careful to write them back exactly as I read them. But it's fine. I can probably add some function like copy. So now I just need to replace this guy with like copy as much as possible. It's not always possible. It's certainly possible here. Yeah, okay. This actually wasn't too bad. Like, it's basically just mechanically replacing reads with copies and things like that, right? Let's see if... Okay, I broke something. And I don't know what I broke. I feel like I broke something fundamental because after the first section it all diverges. So I assume maybe, for example, this guy doesn't work, like would not surprise me at all. Let's see. Let's hear. The offsets are in sync, which is interesting. Huh. Oh, what? This is super wrong. Okay. Alright, this stuff is better. I wish I saved the output or used source control or something. But this all looks legit to me. I think the problem is someplace else. So it's interesting that it says out of bounds right. This means that someplace where there's like a loop or something. Where is this? 186. Oh, this function. Or oh yeah, okay. I was wondering about this. So my read and write functions aren't super correct, and I have a hunch as to why that is. So as we are processing instruction number 65, which is what, like 4.1 in hex. Where's my spec? Okay. Yeah. So there was an instruction that encoded an integer, a signed integer. We read that signed integer, and it could even have been read properly, I'm not sure. But then when we wrote it back, we definitely didn't read anything good. Well, like, we didn't write. We basically are looping forever here, because like you shift the value, you shift the negative value by 7. Oh, there are like also two types of shifts in JavaScript, arithmetic and logical. Is that right? Oh god. Okay. Really though, my question is this. Oh, so I was hoping that JavaScript uses bit operations on 64-bit integers, but I guess it's 32-bit integers. And so I guess what happens is that when you read this thing, it doesn't like read it fully correctly, and then when we write this thing, we don't write it fully correctly either. Okay. Which makes me wish that I used a different approach for handling this. But okay, this is really interesting. So this is saying, I guess this is saying that I can't use bit operations in JavaScript. No, but this is really terrible. Hold on. So right, so JavaScript doesn't even have integers, right? It just has doubles, and it has operations, bit operations on 30-bit integers. Yeah, so this is saying that it's actually hard to write this code in JavaScript properly. Like, it works for small numbers. It works for 32-bit numbers effectively. But what it doesn't do is it doesn't work for 64-bit numbers, for example. Which is unfortunate because, so like this instruction, for example, which is not the one we are stuck on, but it's also an instruction. This one reads differently. Okay. I'm gonna work around this problem for now, because I don't really want to solve this problem, honestly. By saying that we are gonna special case these two copy instructions. Oh, these two like instructions. By saying that we are gonna read the thing. A reading might return the wrong result, but it will read the correct number of bytes. And then we are gonna oh god. So then we're gonna roll it back to where we started from, and then we're just gonna copy the bytes. And this is really sketchy way to do this, but it works. Okay. So now to check if we actually wrote something sensible, let's just like return this data, because the thing is the thing that we return is an array buffer. Okay, and there's a slice, which is cool and exclusive. So for example, if we were to say, let's return the first 8 bytes of the thing, then the rest of the code that processes this WebAssembly blob will actually try to run this, or at least, yeah, like validate and execute, and something will fail, right? So what we can do is we can say, well, let's just return the output buffers portion up until the right pointer. Result. What else? Okay, it worked. Let me remove the console log. And this guy, I guess. All right. It worked. How do we know that it worked? Well, so one thing we could do, like, because we are just copying the bytes basically for the most part. There's no transformations that are going on here. So one thing that we can do that I thought of is, well, let's, before each CMD operation, like the thing I don't know is basically if I actually change this instruction stream in any way, does anything else break? So what I thought of doing was, well, before each CMD instruction, let's just insert a no operation opcode, which is basically this guy, right? So if we insert this before every CMD instruction, then if it doesn't, or maybe after is easier. Let's do it after. After is easier. Then if the code still works correctly, then it must be safe to do this kind of stuff, right? So let's just, after all of this, let's just say, well, let's just write an extra byte. That's just enough. Oh, and now we are hitting out of bounds because now our worst case expansion. It's interesting. Huh. Hold on. Why are we... Oh, it's because I have a typo, of course. So, yeah, of course. Okay. Oops. All right. This is how we know that it's not safe to do this kind of stuff. Section was shorter than expected. Oh, of course. Once we add bytes... Oh no. Oh no. Oh no. Okay. Okay, now. We will need to change this a bit. So right, so like the issue is we made the section larger. Because we made the section larger, we need to adjust the section length. To adjust the section length, we need to go back into the byte stream that we already have mostly written and patch this value. But this value is using a variable integer encoding, so we can't even do that. So the only sane way to do this kind of stuff is to move this bit, which basically reshuffles the code, right, into a separate function. And then have that return a byte blob. Now, it's kind of painful to do this. So So an alternative, this is really hacky, but an alternative is to do this. I can probably remove this stuff. This assert never been triggered, so I don't know that it's useful. Alright, so what we are gonna do is we will say section start, or just start, or start. We will remember the current write offset, and then we will like parse all of the data and stuff. It's really all cleaner if it's in a separate function. It's just that if it's in a separate function, I need to extract all of these guys, and I need to stop using the capture here, and it's all slightly painful. Now let's just make it work first, and then we will refactor this maybe. It's getting kind of late, so maybe we won't refactor this, but maybe we will, we'll see. Or maybe I'll take a break. So we remembered where the section was being written to. Then we wrote a bunch of data for the section. Now what we can say is, well, we could shift we also could just like punt on this problem and just say that if you're extending the section and the variant encoded size is like different. Okay, let's punt on this problem. I want to punt on this problem because this problem is too painful to deal with. The way I'm gonna punt on this problem is like this. I'm gonna record the write offset, then I'm just gonna like write the things I need to write. I will remove this assertion once again because it's not useful. Alright, now I'm gonna say, well, we wrote the section data. Let's remember where we were. Let's roll back the clock to section start +1 because like the section starts where the section ID is, and then there's the size, and then let's just gonna like write the thing, the size, the new size of the section. And you know what, if it's a different number of bytes, then I guess this doesn't work if lab encoded section length requires basically more or fewer bytes to encode. So like if the section was 100 and now it's 101, it's fine. But if the section was 100 bytes and now it's 200 bytes, then you need 2 bytes to encode the length, and then it doesn't work. But I'm getting tired. I want this code to work. The code doesn't work. All right. Does this thing make any sense at all? It seems like it does. A start. Oh, and here we can say actually a new length of the section, right? Oh, no. This is not right. This should be like -5 or whatever. let's see. First, let's stop writing this extra byte. Okay, great. This code doesn't even work. Hold on. Alright, let me just do this. Oh, but then... Oh. Okay, like the issue is basically that there's the offset where the section starts, and there is offset where the section data starts. And they are different. And to compute the length, you need to compute the delta between our current write pointer and where the data starts. But to know where to write it, you need to write it to like where the section starts. Which is all weird and gross, but this now works, and now I can write an extra knob for each instruction, and that doesn't work still. It's kind of interesting that shorter than expected size. Actually, so we had a different problem all along. I didn't realize this. Like, I still need to do the thing I just did. But we had a different problem all along. The problem we had all along is that it stops at like the byte 659 or whatever. Which is relatively close to the start. So it probably stops at like the first CMD instruction or something. For unclear reasons, really. It's kind of curious. If I don't write extra data, everything works perfectly, which suggests that all of these copies, they're all correct within reason. But the thing doesn't work. So let me make some tea because I'm tired a bit of this. And I will continue this. Basically like 2-minute break or something like that. All right. I don't know. It might be too late. So the problem goes like this. We wrote a parser of WebAssembly code. It's like sketchy, but sort of the point was, it's not really a parser, what's the better word? Like scanner or something like this, right? So it basically can scan through the sequence of WebAssembly code and identify instructions. And we can actually make it a bit shorter, which maybe we'll do. But the thing is, we kind of want to be able to modify this sequence of code. And when we try to do so, oh, cool. When we try to do so, by adding a NOP after each instruction, something breaks terribly. So here's the thing I'm wondering about. So like if you do write byte 0x01 here, like the thing breaks. Can I write it someplace else? Like for example, can I just always write it? If I just always, after each instruction, I'm just gonna write one more. Like what happens, right? Hold on. Every time I use the calculator, I have to like, oh dear. So I want to do log of this value. In base 128. Okay. Right now, yeah. Okay. Yeah, I was trying to figure out if after this change there's any problems with the length or whatever. Something is clearly very off. Like if we try to write, maybe it's just not valid to write a NOP. Like the problem is though, I don't know how to test this. Like in an ideal situation, again, the thing that's the reason why I'm doing this work would already have happened, sort of. And then I would just debug this code like on the real thing, but I don't have the real thing, so I'm trying to mutate the instruction stream somehow, but I don't know what permutations are like really valid and what aren't. But I want to mutate the stream in a way that changes its length, because that's what will happen. I think we proved that if we don't do this, like things seem to work fine. It's when we add extra bytes, or extra instructions in this case, something breaks. Oh, I have an idea. Oh no, I'm not using these instructions, I don't think. Which instructions I am using? Let's actually... Yeah, let's just... Maybe this thing is specific somehow to me adding an instruction. Maybe if I don't add instructions, things work. I'm not sure why this would be the case, but... And... No. Alright, let's see which CMD instructions we even use. And our goal would be to take an instruction that has the encoded value of more than 128 and replace it with the one that has less than 128, and then we'll do this in reverse. So let's see, 192, I don't know what this is. Oh, now I have to switch back again. C0. Alright, so this is a swizzle, so that is cool. So let's just say that we will change, we'll do an instruction remap here that will probably break our code in terms of the results that it produces, but hopefully won't break the encoding. So to do real remap goes here, right? So instead of this guy, we will write something else. What's a good instruction that is like that we also use ideally? 12. This is 12, right? So let's just exchange 192 and 12. So let's first do this. Yeah, so the second we change anything, things break. This means we are not doing something right. What might that be? So basically this means we aren't really done, like it's not really about adding knobs, something else is broken. Oh, here's one more thing that could be, oh, I think I know what kind of issue this is. I don't know what's the issue, but I know what kind of issue this is. I strongly suspect that someplace we are accidentally using the read offset, like the write offset instead of read offset or vice versa, because if you don't do this, then the write and read are perfectly in sync all the time, and it doesn't matter if you mix them up. But if you do this, then it's a problem. So this is what I suspect will happen. I have wanted to rename offset to read for a while now. So let me just go and do that. And that way I will effectively uncover all of these problems, I think. Maybe here there is a problem. No, this looks correct to me. Damn it. All of these looked correct. Here we increment the right. Here. Interesting. Okay, so maybe that's not it. Maybe this thing is the thing we are doing wrong because it's incredibly sketchy. Why would this break in the way it breaks? Oh. Their message is kind of curious. Section was shorter than expected size. What does that mean? Does it mean that there is not... Does it mean that the length is too short? Or does it mean that the length is too long? Is unclear to me. Oh, I just had a cool idea. So this code happens to swap these two opcodes. Let's just run this thing twice and see what happens. Because in theory it should like swap them and then swap them back. Oh, it did. Oh, interesting. So our transformation seems actually correct, right? like it changes things around, but then it can parse like the result of itself, sort of. So from that perspective, it seems to work fine. Oh my god, oh. Alright, I know what this is. So there is one more. Yeah, this is the problem. Right. I forgot about this. So it's not just the case that the section has a length. It's also the case that inside the section there's a bunch of functions, which are these entries, and each function has a length. And of course, we aren't patching this length, so of course it's wrong. Okay, alright. Okay, at least it was... Assuming that's our problem, it's probably the last bug we need to fix. So we're gonna fix this in the same sketch way for now. We're gonna take 2 pointers, and then we're gonna ask where we've stopped, and then we'll say and this has the same to-do comment, and I'm hoping it doesn't... I mean, this is where the refactoring comes in. Oh, cool, okay. Now it's actually complaining about something meaningful, which is we changed these opcodes around. This change makes 0 sense, because the input argument types are different, and so we need to swap it with something else. Swizzle takes 2 vectors and returns a vector. So we need to swap it with, like, I don't know, integer equality or something. Alright, our code works, or our code compiles, so I have these unit tests. If I try to run the unit test, then obviously the unit tests don't work because we just broke our code, right? By swapping 2 instructions that do completely different things with each other. But if we stop doing this, then things work. Okay, alright, we are done. Sort of. We have one to do here, which is just, you know, the code isn't ready, which makes sense. We have 2 things that we are doing that are incredibly sketchy, and I'd like to not do these incredibly sketchy things. And we are doing one thing someplace else that is slightly sketchy, but not too bad. But otherwise, this basically works now, which is good. You can kill this thing, and I can kill this thing. Just out of curiosity, let's look at the size of the result. The result is what, like 180 lines or something like this, which is not too bad. I'd like to think about how to make this stuff shorter, because it still feels like I'm doing a bit too much work for what the problem at hand is, sort of. Like, I'd like to be able to do less work. Maybe that's not super realistic, but it seems plausible to be able to do this in less code. Well, okay, the code works. Yay. We can close most of this stuff. Maybe I didn't get what VC was. So what did you mean by using VC? Because I don't understand why it helps with unknown output length. Yeah, I don't fully get the last comment. All right. So, okay, yeah, so recapping, so this code works. Like, the problem is that there is this one chunk of code that is actually doing real work, which is re-encoding the function. And then everything else doesn't really do much, but because re-encoding the function changes the function's length, we need to do like weird fix-ups of lengths in two places, the function and the section after this, which is not great. So the natural conclusion is that we need to like rewrite the function and then just write the length of all of this separately somehow. Like the problem is that, so there's the section length, and then section is a bunch of functions, and each function may have a different length. And so really it would be easier if all of this code was written in, not in the style that I'm writing it right now, which is here's a byte array, just patch things, like write the resulting byte array, but more like, oh hey, here's the function, give me a new byte array with the new function bytes. Because then I can just write this byte array into the output, and then I can write the length, and then I can have a separate thing like that returns a new section. The only problem with that approach is that all of these nice helper functions that I wrote, they basically say where to write the thing to. And that just becomes harder, because I need to think about like separate buffers that I append to or something like that. So all of this becomes just more painful to write. So let me think about how to make this better a bit. What's this byte? Oh, this is a block type. Oh, one other thing I was curious about before I figure out if I want to even refactor this code, how much code it is. Meaning, so we are adding this block of code that you'll have to download and then use that code to fix the code. And the question is, how many extra bytes are you downloading? Like, size-wise, is it better to just add another copy of the CMD blob encoded using the old instruction and the new instruction set? I was hoping that it's not too much code, and it's not the crazy amount of code right now, but I don't know. So at this point I'm a master of gzip. So this beautiful command line prints like the original size of the file, and also prints the gzip compressed size of the file, which is what you would expect the browser actually sends you. The browser might not use -9. This might be a slightly better estimate. Now, without this crazy contraption. Alright, so it looks like this costs us around a kilobyte of download size, and around 4 kilobytes of uncompressed size, which is pretty hefty. However, the whole CMD thing looks like it's 2 kilobytes. So if we had one more like this, that would be different substantially, because every single opcode would be different. Not every single one, because scalar functions are still the same, but like basically it's roughly, most opcodes are different. Most interesting opcodes are different. Then it's likely that we would have paid more than a kilobyte of penalty, because the block itself is like 2 kilobytes. Okay, so in terms of download size, even for something really simple like my library here, which is actually really small comparatively, it seems like a reasonable strategy. So now if this code can be simpler and more robust, like there is a problem with, basically I think this code always works unless these patches of the length break the encoding, which they can, because if you started with a short section and you have to write a longer section, you might have to write one more byte worth of the length date, and that's a problem. So I think this is a robustness issue. Everything else, as far as I can tell, is robust. It's not super clean necessarily, but you know, there's like a limit of cleanliness. Like fundamentally, it's a slightly messy binary format, right? With all of these like weird edge cases. And really what this code is doing is it's enumerating these edge cases. So I don't feel too bad about this. I just don't feel too good about these patches. And it would be nice if the code could be shorter. And I even know how to make the code a bit shorter. I just don't know if I care a whole lot, but it could definitely be shorter. But I kind of want to fix the robustness issue. But it's already like 9:26. Oof. Yeah, you have to, like, you can patch the length carefully. So I can fix the robustness issue technically without rewriting all of my code. It's just like slightly horrible. But maybe it's fine. Like the way it's unfortunate that I mean, obviously the thing I'm doing is slightly weird, right? Like, it's not the usual. If you are writing a tool that processes WebAssembly code, it's probably a tool that runs offline. And by processes, I mean reads and writes. It's probably a tool that runs offline that can completely deserialize your WebAssembly blob into a nice like set of structures, and then can process this, however, and then can write them back. Conversely, if you're writing a thing that just reads the WebAssembly code, you don't have this weird issues with, oh, I kind of want to write something that's variable length, but I don't know the length up until I write it. So I'm kind of in this like worst possible position, right, where I don't want this giant framework that parses the whole thing and then writes back the whole thing in a structured way, right? But at the same time, I'm not just reading, I'm reading, changing, and writing. And so this is why I'm running into this like problem. Now the canonical way to fix this is, and maybe that's what I just yeah, okay, all right. So the canonical way to deal with these situations, if you don't have this weird like length encoded byte stuff, is just that you have a function that reserves space for the length that you don't know yet. And if it's fixed size, then basically you just say, well, I'm just gonna write 4 bytes. And then I'm just gonna return the offset that I wrote them to, and we'll just do write -4 because we wrote 4 bytes, right? And then you just have a function that says patch length that says, okay, given the offset and given the actual value, right, fix it up. And if you have a fixed length encoding, then you just write 4 bytes and you're done. We have a variable length encoding, but actually it's not like that big of a deal, because what we can do is we can say, well, oh, and I don't even need, let's just say that when you say patch length, what you really mean is copy, yeah, okay, I think it's all good. Well, right, yeah, okay. All right, you know what, it's okay. So like in our case, right, the problem is that effectively we don't know how many bytes to reserve before we write the thing, but we could always reserve 4 bytes. These numbers I think are at most, well, I think technically these are 32-bit numbers, but where they are encoded in this format, technically it's at most 5 bytes, I think. So technically I think the worst case is this, because that gives you 35 bits of data, and you need at most 32, but it doesn't really matter. So then what we could do is we could say, okay, since we know where we started, we know the real length, which is our current offset minus start, and the start is, there's like 5 bytes worth of zeros, so this is the real length, right? Then we could just say, well, let's just go back to this location, let's write the length. We know it will fit because the maximum size is 5 bytes, so we know it fits. Now the problem is we need to shift the portion that we have already written back, but we could just do that. Like, there's no rule that says we shouldn't do that, and it's not even slow. Like, it's sort of slow. We don't really care, but even if we did care, it's sort of slow. But if the alternative is to copy this thing someplace else and then copy it back, then it's not even really slower. So because of this, we will just do that. The beautiful thingy has the function copy within, which I'm hoping is safe to use. Oh great, Safari doesn't support this function. Okay, I don't care about that function anymore, but what we're gonna do is we're gonna hold on, so okay, so once we wrote the length, we should just move the data back like a few bytes. What we will do is we will just say write byte, and this needs to be, hold on, so now I have to be careful, result t start plus I. And I think really this is all that there is to this. Like, ideally I would just call a single function copy within or whatever, which would actually be really fast because the JavaScript VM would implement this. But it looks like this method, for whatever reason, isn't supported by Safari. It's probably too new or something. But so I think this would work. And so then what we can do is, instead of doing these crazy hacks, like, I mean, it's still a hack in a sense, right? But it's centralized in one place, and it's actually robust because we don't care if the length changes too much. We will just move things back where they should be. So hold on. Right, and I kind of don't want to go through this trouble when I'm just copying data like as is. So I will do this, or maybe I will do this. I will write this guy, and then if it's code, then I'll say start reserved length. Yeah, I think this will all work. And then I'll just say patch length as start, and then assuming patch length is correct, which I don't know that it is, but if it is, things will work out. Oh, we aren't remapping anything. I forgot. I think this was the instruction. Alright, we have successfully broken our program in a way that patches the instruction. I think last time when we did the swap, we have hit a different JavaScript error. Yeah, okay, cool. Alright, so this works, and now we can do the exact same thing here. And then we don't write the length, and then we don't need this stuff. And then at the end we just say patch length C start, and I think this will all work. Okay, all right. So I think this is good enough, because I think this is like a good solution to the robustness problem, and it doesn't require me to rearrange my code in crazy ways where I start having like different input and output arrays and all of this stuff. This seems simpler, and it's kind of pragmatic. Like, sure, you have to copy the code, you have to like shift the code back, right? But you know, it's fine. Not using copy within, because it's not universally supported. And like, this could be more efficient, right? I don't need to call write byte. I could say, I could directly assign the bytes to the result. Like, this could be results write plus I equals this, and then I could just say write plus equals length. Like, it could be that, which is probably faster, who knows? Okay, this works. And I don't even need to write zeros technically. Here I can just be like write plus equals 5, return write minus 5, right? Because it doesn't really matter what I write, as long as I just need to reserve the space so that when I write the length, I don't overwrite the data that I have already written. So that's cleaner, and we can say that 5 bytes are enough to represent 32-bit length. Yeah. That's kind of it. I don't know. The only thing is, if we can make the code like more concise somehow, that might be good. But other than that, I mean, that's it. We could be like extra fancy and just say, it doesn't really matter. It's fine. Yeah. We could probably remove these guys, because it's like, does typed array not have... I'm surprised that you can even like read out of bounds without triggering any errors. I sort of expected that you would get an error, but you don't. But, what can you do? So yeah, I can probably remove this stuff, but also I could keep it. It sort of protects. It's good if this code actually has bugs. Like, if this code actually has bugs, then these things will highlight these bugs earlier, which is nice. Let's see, what else can I remove here, really? Maybe not, I don't know, like maybe nothing, I'm not sure. So I do need to be able to read these guys, because this determines section lengths and stuff like this. I do need to be able to write these guys, because again, section length is encoded like this. Yeah, that might be it. Like, I'm not convinced that you can write this code in a more concise fashion, I guess, at this point. Like, there's probably tactical cleanup in some places. Like, sure, we can just say something like this. There is like one more value to write, but it's kind of like it's the same code more or less. This piece is slightly sketchy. I don't love this code, but fixing this code requires using 64-bit integers. And using 64-bit integers in JavaScript is probably a bad idea because there's no real type for this. Like, it's not even clear how you do this. So this probably should really stay as is. This should stay as is. This is simple. This is really as simple as it can get. This is as simple as it can get. I don't technically need this because, again, I'm sort of assuming valid inputs, but also if I have unexpected data, then my existing code will just blow up someplace where I don't expect it, and it will be really hard to debug. And with this, at least it fails as early as it can possibly do. So that's good as well, right? Yeah, so I don't know. I feel like this is just complete. Like, I don't think there's much else. I don't really think there's anything else here I can improve, honestly. Right? Normally, my style of code would be to add more comments here, but I mean, most of these comments are really basically, hey, go and read the spec, because that's how this code was written, and that's the only way to write this code is to read the spec. So yeah. Yeah, that's basically it. All right, that means we are done, I think. How long do I think the experimental period will last, and you'll need to keep up the system? So, to the best of my knowledge, here's what will happen. There's gonna be a day X. There's gonna be a day X. Why am I using Notepad for this? So there's gonna be a day X where the change gets merged, right? So let's just say merge change to spec. And this technically could be earlier than, like, technically specification doesn't really directly inform, like, you could have, as we just saw earlier, the specification lists the wrong opcode for one of the instructions, or rather it lists the right opcode from the specification point of view, but no existing tool respects that yet, right? Because it's all in flux, right? Like, the proposal isn't finalized. But let's just assume that this is what will happen. So day X is going to be merge change to spec. So let's say day X plus 1, literally next day, and let's just say day 0, right? Is going to be this. V8 gets the change. V8 is the only major, like, the only browsers right now that implement CMD are V8 and ChakraCore. ChakraCore is the old JavaScript engine, like the JavaScript engine basically in Edge. But Edge is obsolete, honestly. Meaning, if you download new Edge, like, there's an Edge preview that uses Chromium as a backend, so really Edge will go away. So let's just assume there is one JavaScript engine in the browsers, which is V8. And that's really all I care about, because I need to use the browser to test my code. Because, like, the real purpose of my code is something like something like this. So when you run this code, right now what happens is the code that we were just working on, sort of modulo this transcoding bit, actually runs in the browser, right? Like, as evidenced by this. So I care about the browser working, and I can use Chrome Canary, but it's kind of easier to use Chrome Stable, right? And also I care about Node.js working because this is what is easy for me to use for testing, and also this is what continuous integration uses. So V8, and I care about Emscripten because this is the toolchain that cross-compiles C++ towards WebAssembly. So let's assume that the same day, like next day, V8 gets the change. But this means just on get, right? Like the change gets merged to get. And let's assume the same day LLVM gets the change, also in get. And the reason why this is important is that Emscripten uses LLVM. Then my understanding is that it's pretty quick to get a new nightly Emscripten build. So let's just say there's an Emscripten nightly version with the change. And that allows you to build the code. And let's say the same day there's a V8 nightly version with the change, and this is actually pretty easy to get. I use this thing called GSVU, which is the JavaScript engine version updater, which is similar to things like Rust-Up and whatever. And see, I just wrote it and it updated a bunch of code, and what it did is it downloaded the most recent V8 build. And so I think this is super recent. Let's check. Great. Hold on. I think there should be a tag for each release. So this was 129, and this was April 2nd, which is today, right? So then even I think like at the same day V8 nightly, is gonna get this. And then let's say there's 1 day lag from Emscripten. Now then, I use Emscripten from the Emscripten SDK, and this usually has between like 1 to 14 days of lag time. But let's just say that in a week, and this can be accelerated. So let's just say that in a week, Emscripten SDK gets this change. This means that now it's convenient for you to be able to build all of this stuff, and also by default, when you just get the latest SDK, you're going to start using the new instructions. And this is really where the countdown starts for me, because this means, okay, now if I want to use a newer Emscripten SDK, I now have to get this change, right? Then my assumption is that there's a minimal lag time for Chrome Canary. So I'm assuming that, let's just say there's up to a week, I don't know, let's just say it's the next day maybe, let's just say it's 2 days. So keep in mind, I don't have, like, I'm not an expert on this release process, so I could be super wrong here, but this is my expectation. This is all fine. If this was the problem, I would be like, you know, whatever. It doesn't matter. Now this is where the problem begins. So the first part of the problem is between Chrome Canary and Chrome Stable, I think there is 6 weeks. Is that right? Maybe even more. Let's see, so there is a branch point every 6 weeks. So every 6 weeks, the canary is declared as the new milestone stabilization branch. This doesn't mean it's released yet. 2 weeks after the branch point is the first beta. Stable release 7 weeks after the branch point, a new major version is released. 7 weeks after the branch point. And every 6 weeks there is a branch point. This means that you're waiting between 7 and 13 weeks, right? Because if the change gets in the middle of the 6-week period, then it's like 3 weeks. So let's say you on average wait 10 weeks. So day 7 plus week 11, right? Like plus 10 weeks basically. Chrome stable gets the change. The reason why this is important for me is like if I work on my code, I don't want to be in the position where I have to use 2 different browsers to work on my code, right? So this is the real problem for me. But then what's even worse is that, so when we looked at the at Node, so Node Nightly had this excruciatingly old version. I already forgot. October 2019, I think it was. So this is 5.5 months, right? And that's like the best case because, what if their interval is like 6 months, which would mean that your average delay is 9 months? Because if you're in the middle of the interval, you have to wait for the... Does it even make sense? Hold on. Yeah, no, that doesn't make sense. Like, who knows? But let's just assume it's 5 months, right? And so... Alright. And then I have the further problem, which is that I use GitHub Actions. And to use Node.js with GitHub Actions, you have to specify the Node.js version. But I don't think they necessarily support nightlies. They might support only... Like right now, GitHub Actions supports 12 point... I thought that... Was it 12.x or was it 13? I thought it was 13.x. I'm confused a bit. Yeah, so this doesn't make sense. It definitely ran 13.x. So this documentation is also stale. But anyway, I guess what I'm saying is Node.js Nightly isn't even the bar for me, because maybe this means I can't use this on in GitHub Actions, which means my unit tests don't run. So maybe the real thing is like, I don't know, 6 months, 7 months? I don't know. Like release gets a change. And this isn't even the Node stable. I think Node.js is like the biggest problem here. So Chrome isn't great, but fine, at least you can use Canary. Node is like terrible because this just doesn't make sense. So, okay, so I think this is what I'm expecting. Now, this is my worst case scenario. So my worst case scenario is I need this code for effectively 6 months because of Node, and I need this code for effectively, what is it, like 2 months, 3 months. How did I get 10 weeks? Right, 10 weeks was, there's a branch point and the merge, the like release process. Yeah, okay. 10 weeks, wow, really? Nice. So this is 2 months, 2 months and a bit. Basically, yeah, so this adds up total to 3 months, and this adds up total to like, 6-7 months. Yeah. Now, we're gonna have a discussion about this. Maybe there are ways to accelerate this process. All right, like, for example, it's an experimental feature. So maybe it's fine to merge an experimental feature into Chrome stable earlier. And then Node.js is really the long pole, but maybe, maybe you can talk to Node.js team and be like, hey guys, you haven't updated V8 in like 5 months. Please don't update it for 1 more month because of this thing. But after the month, please update it like now because it's been 5 months, right? And yeah, maybe that's... So maybe it's possible to accelerate this so that really Node.js is there even earlier than Chrome, or maybe they come up at the same time in like a couple of months, right? So I feel like my optimistic estimate is 2 months and my pessimistic estimate is like 6 months or 7 months. but we'll see. But really, since I have this code now and this code works, I can't stop like stressing about this. So in the best case scenario, I don't really need this code because, you know, I don't work on this 100% of my time. So my best case scenario is like this thing happens, and then when's the next time for me to get the chance to work on this, it's all there, but that's unrealistic. So my realistic scenario is I need this for a couple of months, but I don't really have to care anymore because this code works. I'll check this code in, it will work. You'll pay an extra like kilobyte of download, but who cares? It's small, and then after this change propagates everywhere, I can remove this code and it's gonna be fine. Yeah, I'm pretty sure you can do, like, I technically don't even need Node necessarily, or maybe I do, but so I have V8 somewhere. Oh, it's in this GSVU folder. Okay. So technically right, but my unit test is basically expecting Node. But like in theory, I don't even need Node necessarily. I could just work with the V8 shell directly, so I can like figure it out, right? But point being, I guess with this code, I can not worry about this stuff and just like have everything just work without me having to mess around with this. And I did spend like 3 hours on this now, right? But hey, it was kind of fun. Now I know exactly how WebAssembly is encoded, which is nice. Maybe it'll help me in the future, maybe it won't. And it's odds are that I would have spent more time kind of trying to figure out how do I install latest node, or latest node doesn't really work with this. Okay, can I get V8 to work without node? How do I get latest V8? And then when I work on this, I need to test this in the browser. How do I do this? Oh, this browser doesn't work. That browser needs to work. Like it's so much kind of mental anguish, right? Where you just don't know, like, is it your code that doesn't work? Is it like the browser isn't the right one? Is it the toolchain mismatch? Like, God knows what happens, right? Whereas with this code, I can be like, oh, hey, I'm switching to the new instruction coding. This code decodes it back if necessary. I'm just done. Oh, I forgot to mention, like, it's technically impossible to query whether the browser that you're in supports this instruction encoding, like the new one or the old one. But the way this works in the WebAssembly world is that you run this really tiny program that really has one instruction that you care about, and you check if this program is valid, like this. And if it is, then you can use this. So what I will do is I will just have basically, like, this is exactly what I will do. Like, I will do something like this. So I will have detector like legacy and the actual detector, or I don't know, whatever. And then I will say, okay, if this is and inside here, instead of this right now, somewhere in this byte sequence has instructions that use CMD, but they are using the current encoding that will soon become legacy. So I will just have a different array here, and I will just say, okay, cool. If this one is valid, then this means that we just use the compiled instruction sequence as is. Otherwise, if the legacy one is valid, we're like, okay, fine, we need to like fix up CMD, and there's this weird unhex thing that we need to do, so it's gonna be like something like this. using legacy CMD encoding. So I think this is basically the code that I will have to write, and that's kind of it, right? So it's not too bad, and this will make me completely resilient to, and right now this will not, I mean, right now this will work, it's just these guys are not like useful. So maybe I should just do that, and then, yeah. Actually. All right, so, I wonder. No. Anyway, that's it, right? So that's all I will need to do, and then this code will work without me having to care about this stuff forever. And then at some point I will be like, cool, I don't need this anymore, I'll delete this, I'll delete this code, that code, I'm done, right? So I'm happy that this seems to have worked out. There is no way for me to test this, but there is going to be a way for me to test this in the future. Anyway. And yeah, I really don't like not having tests for the, not having unit tests for the CMD code, because like the problem is it's different code. It's really hyper specialized, like, right? It's completely separate, and it's really nuanced. There is like some crazy stuff that I'm doing here that should have the same behavior as the scalar code that doesn't do this crazy stuff. And if I don't have a unit test for this, I would just be like, I don't really know that this code even works. And my unit tests aren't super comprehensive, but like, I mean, right? So at this point, since I wrote the tests, I really don't want to work without the tests. Specifically for CMD, right? Just because this code is like sensitive and complicated and stuff. Anyway, all right. So we are at like 3-hour mark or whatever, but we are done. Like there is nothing else to do. So we might as well end the stream. I will share this code just for fun on Gist or something. I will share a link on my Twitter, or I'll put a link to the YouTube, like in the YouTube video description or something. It was fun. Thank you, people who kept me company. Not thank you, people who spam the chat with like stuff that I can't even delete. It's so odd that the chat doesn't like clear up, but whatever. And yeah, that's it. Maybe we'll do this. Maybe we'll do something like this at some point in the future as well, because there's not much else to do these days with all of the virus situation and stuff. All right, thank you everyone, and see you guys later.